So basically today's session will be about the DNS of cloud. If you remember, we've talked a little about Route 53, and it is the DNS service of AWS. It's called Route 53. Why is it called Route 53, especially the number 53? Of course, because if we literally asked what is, sorry, in Arabic. So what is the port of DNS? It's gonna give us port 53. So that's a life hack for you to remember. Route 53 is the port of the DNS or domain name service. Okay. So I'd like to say before we start, let's look at a cheat sheet I have made like a few, maybe 1 year ago. I used it as a personal preference to guide through my DNS records and DNS in general. So let's look through that. It consists of a few pages, like 10 pages. So first thing before we go into the cloud part, so we're going to ask ourselves what is a DNS or a domain name system. Of course, it's a system that translates readable domains into IP addresses. In our networking sessions, we have discussed what does IP addresses mean. We have two kinds of IP addresses. A quick recap, guys. So we have an IPv4 or an IP version 4 and an IP version 6. We said that the IPv4 consists of decimal numbers, 8 by 4, which is 32 bits. And IPv6 is different. IPv6 is written in hexadecimal, and it's 128 bits, 128. So this is like basic differences. Of course, we're going to use them in the records. We have something that's called DNS record. So let's look through that. So in our first, the first problem we had when we were trying to route through servers is how can I communicate to a server? Of course, you need a number, which is an IP number, so you can route to this specific server. So if you remember, if we clicked here 888, it's gonna give us Google DNS. Here you can see public DNS. That's good. So they did not need to know IP addresses. Oh, sorry. Oh, that's good. Thank you for telling me. So let me share my window again and let me go back. Okay. So we were talking about a DNS service. It's a system that translates IP domain names into IP addresses and vice versa. So domain names, IP addresses, vice versa. Thank you for telling me, guys, that my screen is not shared. Okay. So we started with a question, how to communicate with a server or to a server. So how can we communicate? So traditionally, you need an IP address to communicate with the server. So different services have different IP addresses. Remember, if we entered 888, it's gonna go to Google DNS service. And so we have a typical or more than I forgot a protocol. So the main protocol is DNS, which is domain name service, or domain name system, doesn't really matter. And we have what's called a uniform resource allocator, which is URL, DHCP, and NAT. DHCP is dynamic host something protocol. I forgot. Wait, DHCP. It randomly DHCP meaning. Oh, yeah, configuration protocol. I forgot the configuration part. Okay. Okay, so this is how you communicate with the server. Of course, this is our server that we use in like almost anything. And you can see here, you request an answer and it responds. So request response mechanism. This is called request response mechanism. So there are still some scenarios. Okay, if you're not gonna know the IP address, why do we have to go through all of that? Why do we need a DNS, especially as system admins? Why do we need these kind of headaches? So if you're a system admin, if you're someone who's in response or responsible for a system, you need to know some kind of IP addresses for debugging, accessing service or servers on a local network. Also, there's this thing called telnet. It's networking stuff. So you need to know if you want to handle a system or you're going to be responsible for a system, you need to know uh, your IP addresses. You need to know the servers that work on these specific ports, specific IP addresses for debugging, accessing, and a few stuff. Okay. So we have these records. This is, you can see like a languages. Let's, I'd like to compare if we open like Google Translate. So Google Translate is like the DNS service. So if I entered, let's say Ishlibidish, I think I wrote it wrong. That's fine. Yeah. So if I wrote Ishlibidish, which is I love you, or in Arabic أحبك, so I have entered a domain name service in German, and it gave me an IP address in Arabic. And if I switch it up, it's gonna do the same thing. So it's basically the same thing. So of course, there are a few records, and you can think of records as languages. So as you can see, or as you saw, that we were using our Google Translate, we have translated from Arabic to German and German to Arabic, and you can also translate it from English. Oh, that's a good bug. Okay, that's a good bug. That's fine. So you also can translate through multiple languages, and this is what are the records are for. So we have a few records. We have an A record, 4A records, a CNAME record, and an alias record. And we're going to talk until the alias record. We have also multiple. We have TXT, and S, and MX. These are also additional records we can have, but these are what we're going to talk about today. So an A record, or the difference between an A record and an 4A records, basically this is for IPv4, and this is for IPv6. This is the main difference. So used to map domain to an IP address. So domain name is literally, so if we went to Canva, this is a domain name. It's http://www.canva.com. Okay, so this is a domain name, basically. And it's used to route to an IP address. As you can see here, this is, I want an example.com to point at 1234, IPv4. And this is the A record, basically. Example.com, point to 1234 IPv4. This is an A record. For A records, it's the same, but it's gonna point to an IPv6 IP address. So it's gonna map a domain name to an IPv4, which, as we said, it's 128 bits. And it's example.com to IPv6 for A records. So does anyone have any kind of question before we get into the CNAME and alias record? Okay, so we have the next thing, we have what's called a CNAME record. This is from, if you want to go from example.com to blog.example.com. So it doesn't have to route from a domain name to an IP address. No, it routes from a domain name to a domain name, as you can see here. So it points to another domain rather than an IP addresses, and it's gonna be redirected to a target domain. And it is a name that have been assumed temporarily. So example.com, blog.example.com. So also alias record, this is an AWS specific term. So this is not in normal traditional DNS records. This is only AWS specific. So alias records are used to route to different kind of services like ELB and a lot of things, or CloudFront, let's say. So they allow to map the domain to certain AWS services such as ELB and CloudFront. And that's it. So this is the cheat sheet. This is a brief introduction about Route 53. We have talked about DNS. It helps us translate between a domain name and an IP address, or or IPv4 and a domain name and IPv6 or a domain name with another domain name. Okay, so let's go to Route 53, and we said 53 is the port of the DNS. So, of course, content table, we're going to talk about an introduction, key features, how it works, routing policies, health checks and monitoring, use cases, and some benefits. So, I think one of the most important things in this slide is the routing policies. These come a lot on my exam, and it came in my exam as well. So, introduction. So, DNS is a service, or Route 53 is a service that handles the DNS, and it's designed to route end user requests to internet applications, of course. So literally, if we want to have, or if you want to launch an EC2 instance, we're going to have a domain name that is from Route 53, and we're going to see that right now. So I don't really like, oh yeah, here you can see, such as EC2 instances, load balancers, and a lot of stuff. And we're going to try this out right now. So key features, first thing, we have what's called a domain registration. We have DNS routing. These are very close. I can't even read. That's fine. So we have domain registration. If you know GoDaddy or Wix.com, or there's, I think, a lot of DNS registration or domain registration applications. But if you want to have, like, let's say I want Maya.fun, I think it's available. So let's go GoDaddy. And let's say I want, here you can see domain.com, GoDaddy, yes. So let's see, I want Maya. Let's see what we can have. I think I don't want Maya.com, I want Maya.fun. Here it is. Oh, wow, that's really expensive for the first year. Okay, I don't want it anymore. So you have a lot of domains, as you can see here. So this is domain registration. If you buy one, if you buy Maya.co, which is approximately $90,000, it's gonna be yours. It's gonna be registered under your name. So you can't buy Google.com. It's registered to the company Google. You can't buy AWS.com because it's registered to AWS. So if you registered and paid, you can't have this domain name. DNS routing, of course, it's how we talked about routing and how it translates domain names into IP addresses and vice versa. Traffic flow. Also, it can help us using what's called routing policies. We're going to see how it's going to help us with DNS failovers and traffic flow. So integration with AWS services, you can integrate it with multiple services like S3, EC2, ELB, and CloudFront. Also domain name management, you can have features, records like AWS records, CNAME, MX, NS, and PTR. Private DNS, so what is interesting about private DNS? In private DNS, you can have the domain google.com, but it's not accessible via the internet. That's why it's called private. So you can have any kind of domain you want, but it's not going to be accessible via the internet. It's for like internal corporations. So let's say you hate this someone, okay, and you think this someone knows everything. So you give him that domain name of google.com because he knows everything and he is annoying. I don't mean that Google is annoying. He just knows everything. So, in Arabic we call it Ammo Google because it helps us. Ammo Google because it helps us. Okay, so how it works. This is a lot of talking. I hate that theoretical part, but it's fine. So first thing, you have to register a domain. Of course, you have to buy one. So for myself, I'd buy Maya.fun, but it's really expensive. It's like $350. So no, thank you. Then you create something that's called a hosted zones. It contains the DNS record for a domain, and it creates public or private hosted zones. So based on your demands, you can have either public or private hosted zones. Configure DNS records. We've talked about records, so you can have A, 4A, CNAME, and other, like alias, MX, NX, whatever. Also, you can configure health checks, and we have talked about health checks. You remember health checks. We've talked about them in the ELB and ASG session, or load balancer and auto-scaling group session. So also Route 53 have these kind of capabilities, which is health checks. And you can apply routing policies, and we're going to talk about them right here. So it's number 4, and you can monitor and optimize using CloudWatch, using metrics. You can see if you can lower your cost, and you can optimize your preferences. So we have 7 routing policies, and we're gonna go through them. So first thing is the simple one. And you have one website, and every time someone actually visits this website, it's going to go to the same service. So let's have our server and EC2 instance. Okay, here's our server. And here is our user. So let me do this. That's a huge server. We don't need that much. Okay, so simple policy is basically is just like this. So every time, oh, that's a bad arrow. So every time someone wants to visit your fun.com, my.fun, it's gonna go to the same server over and over again. So if you remember in our ELB session when we made our hands-on labs, we have created three EC2 instances, and every time we refreshed, it went to another server. So that's good. So as we said here, same, it's not gonna graphic. So here basically it routes traffic to a single resource. So weighted routing. You have 2 servers for your website. You send more visitors to the stronger server and fewer to the weaker ones. So you can distribute traffic across multiple resources based on specific weight. So let's say we have a bad EC2 instance, or not bad, it's just like half bad, and a very good one. So here we can have like 2 instances. Let's make them small and delete this one. Okay, let's say this is a good server. So let me have the green one or red one. This is like bad. Not bad, just half bad. Let's say you don't need to use a bad server. And this is the good one. So basically, routed policies is gonna send more users to the good one. So it's gonna send more users to the good one and less to the weaker one. It's an example, of course. It's not. You can specify your own weight based on your business case, but this is just an example of it. So latency-based routing. So you have servers across different countries, and every time, let me show you. So let's say I don't like reading out of all of this. So let's say this is in India, and this is in the Middle East. And let's say this is in, I need a country that's close to India. I can't think. So let's just say he's in India. Okay. So this user is in India. Of course, latency based is gonna send him to India. But if he is like me and he's in Jordan, so let's get that in green color. And let's say if this guy is in Joe, which is Jordan, he will go to the Middle East. This is latency-based routing. So it's gonna lowest network latency for users. Of course, we have said the lower the latency, the better. So lower latency, the better. Better. Okay. So let's check the 4th one. So we have what's called failover routing. Okay, so basically failover routing. So let's say we have this user right here. I stuck on the letter S. That's weird. So we have this user on the server right here because we're using a lot of words that has us. And the server starts shutting down. So it starts crashing and start having problems. So it's gonna route him to this one right here, and then this user, again, I'm stuck on the S, it's gonna go to this server. Come on, those are a lot of S. So failover. So you have a primary server to your website and a backup server. If the primary one goes down, it's gonna send the visitors to the backup server. Okay. Of course, there's a few things you need to consider. It's not gonna fail over immediately. It's gonna take like 2-3 minutes to fail over because this user has a specific session. So it's gonna take a few time or a few minutes to fail over. Geolocation. So if you have visitors from different countries to see content that is tailored to them. So basically, let's say again, if we have an Indian, a server in the Indian region and one in the Middle Eastern region, and this guy is Arab, like myself, I'm gonna send him to the Middle East, and this content is tailored to him. So let's say, of course, there is cultural differences between India and Middle East. So if this guy is from India, it's gonna be tailored for him and it's gonna go to the India region. But if he is Arab, he's gonna go to the Middle East region and he's gonna find content that is tailored to him. Let's say like when you're having an application that translates into multiple languages, you have certain type of dialects, you have certain type of languages, your spoken language, you know. So let's say here in Jordan, we speak Arabic, we speak our our different type of dialects, and of course Tunisia, Morocco, they also speak Arabic, but they're different from us. So let's say me and someone from Morocco, we can have the same type of content. It has to be tailored to their own needs and their own understanding, and my application should be tailored to my own understanding as well. So this is geolocation. See. Okay, geoproximity, it's when you want to route servers in a specific regions more often, and this is slightly farther away, it's gonna adjust based on the proximity. So let's say if we have, let me think of an idea. I'm trying to think of an idea how I can explain it to you. So if you want to route traffic to services in specific regions more often, then they're slightly farther away. Okay, so it's basically like latency based or latency based routing. So let's say we have someone in California and the other in Texas. I don't know how Texas is written. It's very wrong. Wait, Texas. Texas, yeah, I've wrote it correctly. Okay, so Texas. This is an X, guys. This is not T. So California, Cali, and Texas, and this guy is from, let's say, Miami. I don't think this is the cloud lecture. I think this is a geography lecture. حاسس حالي عم باخد جغرافيا. So this guy is all of the servers are from USA or the United States. So let's say I prefer everyone that is close or in USA to go to Texas and they will go to Texas, not California. Even though let's say or hypothetic let's imagine that Miami is closer to California, but I wanted to go to Texas, even though it's much closer in California. Okay. So multi-value answer, it returns multiple values such as IP addresses, and it can perform basic health checks. So you have multiple resources and you want to distribute traffic among them. So basically you can think of this as load balancer. So multi-value, you have multiple EC2 instances, but you have ELB, and this ELB will give you a value every time you visit. Different, it doesn't, like, it's very random. So you don't have any kind of specific or something specific to follow. It's just pure random. As you remember, in our ELB lecture, we have initiated a load balancer, and every time we refreshed, it gave us a random IP address. So this is the multi-value answer routing. Okay, so basically this is the most important part. So we have the simple one, which is one resource, just gonna route to it, weighted based on different weights you apply to. So let's say we have a strong and a fewer and a weaker server, it's gonna send you to the stronger one. Latency based, so it's gonna send you to the fastest and closest resource there. Failover routing, we have a primary and a secondary one, and the primary one is failing. So it's gonna start sending visitors to the backup server. Geolocation, we've talked about the guy in India and the guy in Middle East. So if you're in India, you need someone that is tailored specific to you. Or let's say, like me in Jordan and Morocco, both Arab countries, but the people in Morocco speak different Arabic. It's like a mixture of Arabic and French. And here it's pure Arabic. So we want something that's tailored for them and for us. And that's what geolocation routing does. Geoproximity, we have said about the one in Cali and in Texas. The guy or the user is in Miami. So let's hypothetically think or imagine that Miami is closer to California, but either way, we're gonna send it to Texas because maybe Texas is more strong. The server that's in Texas is more strong. And a multi-value answer, we said it's like the ELB. So quick recap. So I want to like stop and then continue with these. So let's go and check the Route 53 service on AWS. So you can see here DNS management, traffic management, registration, availability monitoring, and you have a lot of stuff. So you can create health checks, create hosted zones. So let's create one. We can have maya.thetechstuff.com or .edu, let's say .edu. And this is, I want it to be a private one. So choose the region. I want it close to me, so I want something in the Middle East, maybe. I can't even find one in the Middle East. That's fine. I'm just gonna choose Virginia and the VPC, and then we can create a hosted zone. So that was very easy. So you can see here, we have created, and the routing is simple, and we have created two types, an NS type and an SQA type. That was like quick and easy. So if we want to create an EC2 instance, so let's do that. Let's just create a basic instance, and that's it. So I want a very quick and basic instance. So let's have this instance running. Launch an instance. So let's call it test DNS. I'm gonna keep all of the defaults. I don't want any kind of key pair. Select existing security group. So launch wizard 1. And just launch instance. I just want to keep everything basic. I just want to show you guys something. Okay. So let's just give it a moment. And until it launches, let's go back. So we have this what's called a health check and monitoring thing. So we can have regular health checks to remove unhealthy resources, and we can use CloudWatch to do that. And we have talked about this and used it in the autoscaling group session. So if we went here, we can see that we have a public IP address and a public IP DNS. So let me connect and install Apache on it so we can see. So let me update. If I like open it, is it gonna show anything? I don't think it will. There's nothing on it. So I want to install Apache. Yeah. See HTTP. Yeah, there's nothing on. So system CTL update. I'm sorry, update. Oh, not system CTL. Yeah, I forgot. So sudo apt get, or that's no, yum update. Okay, nothing to do. Sudo yum install Apache 2. Is it called Apache or HTTPD? Okay, so it's HTTPD. Yes. Okay, very quick. It's completed. That's very quick. So let's say system or sudo system CTO. Check or status without check status. Status. So it's running. It's okay, clear. So maybe now if we open this and we apply the HTTP protocol. Oh wait, I opened I opened the trunk. That's fine. So I'll just do this. It's gonna, I think, open the Apache server. Have it. Wait. Let me try and start it. So system CTO HTTPD start or enable HTTPD. Okay, then we're gonna start the service. Okay, so let's open the DNS and remove the S because it works. Good. So here we have used the IPv or the IPv4 DNS. And I think if we open the also version, it has to open the same thing. Yeah. So those are the same thing. The difference is you can see here the domain name is ec2.amazonaws.com, and you can see here this is only the IP address. So those are different. And those are, by the way, in Route 53. So you can check these out in Route 53. So that's basically what I want to show you, that even in EC2 instances, you're going to have domain name and you're going to have Route 53. And it's a very important concept to consider and to study about. So terminate or delete instance. That's fine. Okay, so use cases, we have multiple use cases. We have global app delivery. Of course, it's going to help us to globalize our app. We're going to have high available websites. We're going to have load balancing, of course, because of health checks and routing policies. Security and compliance, it uses this protocol, which is DNS security protocol to protect data. We have private networks, and we've talked about private hosted zones. And the benefits, we have high availability and reliability. We have scalability, we have security. We have talked about this multiple times. It's cost effective and it's easy to use. Okay, so if we went back to Route 53, you can see here we have one hosted zones. We already did that. So let's create an health check. As you can see here, so I forgot what was the name. So Maya dot text stuff. I think I have to buy a domain name. So endpoint, we can status. We have a lot of things. So it can be HTTP, the port, the path. We can like incorporate all the paths we need. So we can also create a health check, and it's gonna track your health checks based on multiple things. Let me remove the hosted zones before I forget. So hosted zones. I don't have I don't have a DNS name. I don't have any DNS registered by my name, so I can't like show you a lot on this section to be specific. But that's it for today. Yeah, it was a very quick session as well. I've told you guys all the sessions from now on are gonna be very quick, except I think the S3 one. And that's it. Let me stop the recording.